With trials underway, the submarine tests the reactor under real seagoing conditions.
Welcome to our factory. Today, I'll show you exactly how nuclear submarine reactors are made, step by step.
Each nuclear submarine reactor begins as a detailed digital design and safety requirements into a single model.
The stress visualization confirms the turbulence. Monitor the boiling margins in that accelerated region.
Analysis complete.
Activating the failure scenario now.
We have primary pump failure. Initiating recirculation protocols. Watch the secondary cooling lines.
According to the material certificate, the yield strength is significantly higher than expected.
Vessel components start as massive steel ingots, cast from careful controlled nuclear-grade alloys.
Base, this is Unit 4. Surface prep on Ring Assembly 3 is complete, ready for inspection.
Fine machining brings the vessel bore into micron-level straightness and surface finish. Massive vessel sections are aligned with laser-guided precision before welding into a single pressure boundary.
Within a controlled environment, the reactor's internal structures are assembled for accuracy and cleanliness.
slowly now, bring it down gently.
Watch your clearance on the left side. Okay, easy, easy. It's set.
Around the reactor vessel, primary loop equipment circulates coolant and transfers heat to the submarine's power plant.
A full-scale compartment mock-up replicates submarine space constraints for precise reactor module integration.
Bring it down easy. Watch your clearance. Slow down, slow down. All right, secure.
Clear here. Looks like 45 centimeters to the insulation. 45. Got it. Check the emergency route next.
Checklist complete for Module 4.
Tools secured, lugs installed.
Confirmed. Ready for transfer. Control panels provide the human interface for monitoring and operating the reactor.
Over-temperature alarm on channel 3.
Acknowledged. Initiating scram sequence now.
Confirm trip logic active.
The reactor pressure looks stable at 50 megawatts.
Acknowledged. Check the coolant flow rate on panel 3.
Comms check successful. We are reading a slight variance on the R3 gauge. I see it. The hotspots confirm operator focus remains stable.
Power levels spiking in reactor 1. Initiating scram sequence now.
Verify coolant flow immediately. We need stabilization before it hits the trip limit.
Sequence initiated. Cycle the main coolant valves now.
Confirmed. Pressure stable. All systems showing nominal parameters.
Reactor module verified.
Good work.
Before any fuel comes near the reactor, cleanliness standards tighten to protect both components and nuclear safety.
Swab complete, beginning retrieval. Copy that.
Analysis shows minimal particulates. It's a pass.
Review complete. All conditions are met for fuel loading.
QA approves the release.
Independent regulators and naval authorities scrutinize every stage of the reactor's build.
The heat number here is 7432.
Verified against the material test report. The weld looks good.
All right, let's review this section. Flawless weld. Accepted.
The core damage frequency is now well below the acceptance line.
Does this account for the seismic reassessment?
Yes, it includes the updated external event data.
The certification is approved. We still need to finalize the documentation and ensure all conditions are met before deployment.
Moving a nuclear reactor module requires meticulous planning to manage weight, balance, and safety.
Continue descent, slow and steady now. Watch the starboard side.
Copy that. Starboard clear. All clear. Set her down.
The clearance on the red cable seems tight.
It's within the parameters. I'll make a note on the sheet.
At the pier, the submarine systems are connected to shore for integration and testing.
Control, this is primary loop. Injection proceeding as planned. Levels are stable and bubble-free. Reading is stable at 150.02 psi.
Matches the reference standard. Calibration complete.
Check the primary loop pressure immediately. Alarms are confirmed.
Pressure stabilizing. Engaging secondary coolant now.
Control room to maintenance, the test was a success.
Simulation holding steady at maximum output.
Live test successful. Thumbs up confirmed on Channel 3.
Cold commissioning is complete. We are ready for the next phase.
It's been a long road. Congratulations.
Nuclear fuel fabrication occurs at specialized, secure facilities under strict international safeguards.
Specialized transport moves fuel under tight security and regulatory oversight.
At the dock, specialized handling systems prepare to safely transfer fuel into the reactor compartment.
Checklist item 12, verified and logged.
Confirmed. Status remains green.
A detailed briefing precedes any move toward first criticality.
Requesting withdrawal of Bank 4, 5 steps.
Bank 4 withdrawing 5 steps. Reactivity response is stable.
Acknowledged. Neutron flux steady at 75%.
Reactor critical, low power stable.
Achieve that.
Initiating rod response check on Channel 3. Predicted curves matching measured data. Proceed to next sequence.
Initiating reactor scram. Verify rod insertion and monitor neutron flux.
We have confirmation on low power physics and hot functional.
The data supports the conclusion. Sign off on criticality.
All items complete, sir.
With trials underway, the submarine tests the reactor under real seagoing conditions.
We have a partial power failure in Sector Gamma. Reroute coolant flow immediately.
Control to maintenance, check valve 7B. We have flow destabilization.
Ramp up complete, holding steady at peak capacity. Initiating controlled power down sequence now. All systems nominal.
It is my honor to accept this plaque and formally recognize the successful completion of the reactor plant.
Unit 7's indicators are fluctuating.
I'm pulling the thermal data now.
Powering up the new rack now.
All parameters nominal. The upgrade is complete.
The fluctuation spikes correlate directly with the degradation incidents.
But the improvement data suggests we can integrate the new moderator design to compensate.
And that's how nuclear submarine reactors are made, from start to finish.